function has 0 value everywhere except at t is equivalent to 1, and at t is equivalent to 0, the amplitude also is said to be an infinite amplitude. Now how do I write that then? This delta function, delta of t, will be equivalent to u of t. We know that delta function is equivalent to that of your unit function. That means now I need to perform the derivative of that one. Therefore, d divided by dt into u of t. So, u of t here is s into 1 divided by s here. So, when I take the differentiation of this, then it will be equivalent to 1. S and s gets cancelled here. Here also s and s gets cancelled. So, since s and s gets cancelled, I will be getting the output as 1. Now, what is the final conclusion here? The final conclusion that I am making is the symbol which is used to represent our unit step function is u of t, and what is the response that I am going to get? The response for this particular function is 1 divided by s. Similarly, for the unit ramp function, I will be denoting it as r of t, and the response that I will be getting is 1 divided by s square. The next type of function is called as the unit parabolic function. We don't have such symbol to represent the unit parabolic function, but what is the response that I am going to get is 1 divided by s cube. And the last one, the last standard signal is the unit impulse signal, and this is denoted by delta t. This is denoted by delta t here, and the function that I will be getting is nothing but equivalent to 1. So these are the 4 things that we have to remember. Only if we remember this, then it will be easy to solve the problems, because in the problems they may ask you that they may tell you that the input is unit step. The input can either be a ramp one, or it can be a unit parabolic or an unit impulse. Then whenever r of s you are considering, the r of s should be considered with respect to these things. So if it is unit step, your r of s value will be equivalent to 1 by s. If the input they are telling in the problem to be a unit ramp, then consider r of s to be equivalent to 1 by s square. And if they say that the unit parabolic function is the input, then it has to be replaced by 1 by s cube. R of s will be equivalent to 1 by s cube. And if it is unit impulse, then the value of r of s will be replaced by 1. Next, let us study the time response with respect to the first order system. Now, with respect to the first order system, how do I write the first order system? Always the first order system is written by 1 divided by s into t plus 1. S into t plus 1 is how we write the first order function. Now, whenever I write 1 by s into t plus 1, this should be what? The response from the system. The response from the system means what? Any system I have, r of s will be my input. This will be the system which will be available here, and my output will be equivalent to c of s. Now, what is the response of the system? 1 divided by s into t plus 1 is the response of this particular system. Therefore, if I want the output divided by input, then this divided by this. So, I have it here as c of s divided by r of s, which is equal to 1 divided by st plus 1. Now, if I want only the output function, then what do I do? Whatever r of s was there with respect to the denominator, that I am going to shift it this side. Therefore, 1 by s into t plus 1 into r of s. Now, what we will consider is, let the input be equivalent to the unit step. If the input is equivalent to unit step, what is the value of r of s we are supposed to consider? The value of r of s we are supposed to consider is nothing but 1 divided by s. Therefore, what will be the new term of c of s here? I substitute the r of s value here. Therefore, this r of s will be substituted by 1 divided by s. So, 1 divided by this function as it is, that is nothing but s into t plus 1 will be equivalent as it is extra function which is nothing but 1 by s. That 1 by s is nothing but this. Now what I have to do, whatever the c of s function I have got, to this c of s function I need to apply the partial fraction to that. Now when I apply the partial fraction, all of you have studied this in the mathematics class. So how do I apply the partial fraction for any system like this? So for partial fraction for any system is this. I am going to separate. So 1 divided by s minus this function now t divided by 1 plus s into t is the second part. Now what I have to do now? Now I will be taking the inverse Laplace of that particular function. Now if I take the inverse Laplace, what is 1 divided by s? 1 divided by s was the inverse Laplace transform of 1 divided by s is nothing but equivalent to 1. These are the standard formulas with respect to the inverse Laplace transform. Similarly, that means inverse Laplace transform of 1 divided by s is equivalent to 1. So the same one I have substituted here. And what is the second part? The second part is t divided by 1 plus s into t. So what is t divided by 1 plus s into t? It will be the inverse Laplace transform of this particular function is e to the power of minus t divided by t. Therefore 1 minus of it is minus is already there with respect to what? With respect to the partial fraction. Therefore, inverse Laplace transform of t by 1 plus s into t is nothing but e to the power of minus t divided by t. Now what I have to do? I have to put whenever small t is there to be equivalent to capital T. And what is this capital T? This capital T is called as what? The time constant. And what is the time constant? The time constant is defined as the time required for the signal to attain 63.2% of its final or the steady state value. That means what? If my graph is like this and if I exponentially increase it, right? If this is the time that is requiring, if this is equivalent to 0.63, then whatever this particular time is there from 0 to 63%, that t is nothing but the time constant capital T. So here I can see that 1 minus e to the power of minus 1. How did I get this 1? Because I substituted wherever small t is there as capital T accordingly. So 1 minus e to the power of minus t by t. So e to the power of minus 0. So exponential to the power of 0 is nothing but equivalent to, so e to the power of minus t by t. So e to the power of minus 1. So this is nothing but e to the power of minus 1. Now when I put this in the calci, you will be getting this as 0.632. So depending upon this value, we have told that it is the time that is required for the signal to attain 63.2% of the final or the steady state value. Now you can see here, whatever the time constant is there, that is nothing but the capital T, it indicates how fast the system reaches to its final value. Similarly, this time constant is faster if the system response changes. Now you can see here. Now what we are going to do is, previously I considered the input to be the unit step input. Now what I am doing? I am considering the input to be my unit ramp function. If I say unit ramp function, what is the substitution that I have to make for R of S? For the R of S, I have to make the substitution as 1 divided by S square. Now until this, whatever we did it in the previous derivation, it is the same. So C of S divided by R of S is what? 1 by ST plus 1. Now if I want this R of S here, then what is C of S equivalent to? 1 by ST plus 1 into R of S. But since I am considering the input to be equivalent to a unit ramp here, I'll consider R of S as 1 by S square. Now I will substitute this in this particular position. If I substitute that, then it will be equal to 1 divided by S square into 1 plus ST. Now what I will be doing? I have to again take the partial fraction for this. Now whenever a square is there, anyway I know for this part how to take the partial fraction from the previous one. So whenever I have a square part here, then it is 1 divided by S square minus t by S plus t into 1 by S plus 1 divided by t. Now what I will be doing? I have to take the inverse Laplace transform. So 1 divided by S square. So here you can see here it is equivalent to t. So inverse Laplace transform of 1 by S square is how much? Inverse Laplace transform of 1 by S square is nothing but equivalent to t. t. Then t divided by s. That means 1 divided by s inverse Laplace with respect to the constant t. So how much is the inverse Laplace transform of 1 divided by s? The inverse Laplace transform of 1 by s is equivalent to 1. 1 into t is how much? It is equivalent to t. Therefore, I substituted the value here as t. Now, I need to take the inverse Laplace transform for this. 1 divided by s plus 1 plus t. So, this capital T is constant. What is the other part? It's an exponential part. So, e to the power of minus t divided by t. This is the equation with respect to c of t if I consider an input to be equivalent to what? An input is said to be equivalent to unit ramp function. Now, if I want to find out the error for this particular thing, then what is the error signal which will be given? Error signal will be always equivalent to the input minus the output. Suppose if the input minus output you are going to do, if you are going to get some value here apart from 0, then I will say that there is an error which is being introduced into the system. Now what I do? To this I am going to substitute what is my C of t value. E of t is equal to, what is the value of R of t? R of t, I am keeping it as it is, that is nothing but t. Why t? Because it is nothing but a unit function. Unit ramp function. Therefore, my input is nothing but t minus C of t. Where is my C of t value? This C of t value completely has come from this. But what is your R of t value? This R of t value is nothing but equivalent to t, which we have already done from the previous derivation. So from previously we are checking what is the value of this R of t. Right. So here R of t is equivalent to t minus C of t. I am making this substitution. Now what I do? I open this bracket. If I open this bracket, this t and this minus t gets cancelled. So what is the remaining term? Minus t plus t into e to the power of minus t divided by t is nothing but remaining term. Now can I take here t and t both common here? Since I am taking t as common and I shift this minus towards this side, t I am taking outside. But here there is a plus sign and minus sign is here. So plus into minus becomes what? Minus. This term I will write it as it is, e to the power of minus t divided by t. Now, what is the steady state error here? The steady state error says that limit t tends to infinity, t minus t into e to the power of minus t divided by t will be equivalent to capital T. Why? Because wherever this small t is there, I am tending it to infinity. So, e to the power of minus infinity here. So, this part can be a negligible part. Therefore, the value that I will be getting will be equivalent to t. Now, what is the steady state error equal to? The steady state error is equivalent to t, and what is this t? This t is said to be the time constant of the system. For smaller time constant, this steady state error will be small and the speed of the response will increase. This is the final conclusion that we can make with respect to the steady state error. Okay. Now, if I consider the input to be the unit impulse function, then what is the derivation? We will see now. R of s, now I have to consider it as 1 because what is the type of function that I am using? It's a unit impulse. So just recall this. So if I recall this, what is R of s equal to when it is in the case of an impulse function? So that will be equivalent to 1. Okay, so your R of s will be equivalent to 1. Same equation. C of s by R of s was 1 by st plus 1. I want only the output this side. I shift my input towards this side. Therefore, 1 by st plus 1 into Rs. But what is the value of Rs? R of s value is equivalent to 1, which we have already written it here. Therefore, your C of s is equal to 1 divided by s into t plus 1 into 1. Where this 1 is nothing but the R of s value. Now again, what am I supposed to take? This equation now becoming what? This equation is now becoming 1 divided by s into t plus 1. But for the purpose of simplification, what I will be doing is, I am taking this t outside. If I take this t outside, then t into s plus 1 divided by t. Correct? Now, even when I take the inverse Laplace transform for this, 1 by t is a constant term which will be kept as it is. 1 divided by s plus 1 divided by t. What is the inverse Laplace transform for that? The inverse Laplace transform for that is e to the power of minus t divided by t. How am I getting the response now? This is the unit ramp response of the system. Here, whatever the difference that you are going to get between r of t as well as c of t is nothing but the time constant t. And this time constant t is nothing but your steady state error. So, this will be your output. This is nothing but the input. In between this, whatever the error that you are going to get is nothing but the steady state error. And unit impulse response for the system, how do I write this? It is decreasing like this. Why? Because in the previous one, you can see e to the power of minus t divided by t. Since minus is there here, it means it has to come down. It has to come down. That means it is exponentially decreasing. It has to go down. Therefore, from 1 by t, it will come like this. So, whatever the slope that I am getting, this slope is a function of what? 1 by t into the e to the power of minus t divided by t. Now, let us compare all the three responses. First, let us take the unit ramp input. So, when I took the unit ramp input, what was my r of s that I considered? Since it is a ramp function, 1 by s square was the function that we considered. Therefore, what is the output function I got? T minus t plus t into e to the power of minus t by t. And when I considered the unit step input, what was c of t equal to? 1 minus e to the power of minus t divided by t. When I consider the unit impulse response, my r of s was equivalent to 1. And what will be my c of t? 1 by t into e to the power of minus t divided by t. Now, observing all these three, what can we prove that? It is clear that when the unit step input is the derivative of the unit ramp input, unit impulse input is the derivative of the unit step input. This is the property of your linear transfer system, time invariant system. Right? So, here you can see here, this and this is having an exponential term here. Unit ramp and unit step impulse input is the derivative of the unit step input. So, part you are getting here and part here you are getting. So, from the unit step you can derive the ramp as well as you can derive the impulse response also. Now, all these things was with respect to the first order system. Now, let us move on to see with respect to the second order system, what are the different analysis that we are supposed to make. So, next is time response of the second order system. Let us consider a feedback system, a unity feedback system. When do I say that the system is said to be a unity feedback system? Whenever I take a feedback, here is my h of s and this is nothing but my g of s. When the h of s value is equivalent to 1, then I say that the system is said to be what? A unit feedback system. And what is the value of g of s? The value of g of s is omega n square divided by s into s plus 2 into zeta omega n. Now, unit feedback system here. So, a negative feedback here and a r of s value here. Now, how do I write output divided by input? My output divided by input will be omega n square divided by s square plus 2 zeta omega n s plus omega n square. Right? This will be my c of s divided by r of s and this I call it as my equation number A. Now, if I want only the value of c of s, r of s, I am going to bring it this side. Now, after that, again, let us go back. If the input that I am going to consider is r of s, then what is the function we will be using? The function that we will be using is 1 divided by s. So, what I do now, wherever r of s was there, I am just replacing r of s by what? 1 divided by s. Therefore, 1 by s into the remaining term whatever was there. This term I am writing it as it is. Only r of s now is replaced by 1 by s. Let us call this to be equation 1. Now what we will do is, whatever this part of the equation is there, that is s square plus 2 zeta omega ns plus omega n square is there, that I will be replacing by what? S plus omega n the whole square. Now why am I using it like this? That is because what is this? It is in the form of a plus b the whole square. What is a plus b the whole square? A plus b the whole square is nothing but a square plus b square plus 2ab. So the same thing it is here. So s square plus 2 zeta omega ns plus omega n square, I am writing it as s plus zeta omega n the whole square. Then what I am doing? Add and subtract with omega n square is what I am doing. So what I am doing is, totally I am replacing s square plus 2 zeta omega ns plus omega n square as s plus zeta omega n the whole square plus omega n square into 1 minus zeta square. Now what I do? Let us substitute here. This 1 by s term is kept it as it is. Whatever the second term is there is replaced by s plus zeta omega n the whole square plus omega n square into 1 minus zeta square. Now let us break the equation by partial fraction, and also wherever omega n square into 1 minus zeta square is there, for the purpose of simplicity, for the purpose of simplification, we will equate that term to another term which is called as omega d square. Therefore, omega d square is equal to omega n square into 1 minus zeta square. Now what I will do? Wherever this part is there, I will just replace that by omega d square. So what will be after, and also we will be applying the partial fraction method. So 1 by s, this I am rewriting as it is. So here a by s plus b divided by s plus zeta omega n the square plus omega d square. Let us call this to be my equation number 3. Now let us consider the value of a to be equivalent to 1. If I consider the value of a to be equivalent to 1 and also multiply this particular equation number 3 by s plus zeta omega n square plus omega d square and put the value of s to be zeta omega n minus j into omega d, and the value of b to be equivalent to what? Omega n square divided by s. Now how do I get this? This here whatever is there is b value. So omega n square divided by s. What is the s substitution that I am making? The substitution for s I am making is minus zeta omega n minus j omega d square. Now let us write it here. Omega n square divided by what I am going to do here is minus zeta omega n minus j omega d is there. Both in the numerator as well as in the denominator, I am adding and subtracting that. I am multiplying that. By what I am multiplying? This I am going to multiply as a complex conjugate. So when I multiply that as the complex conjugate, in the numerator, since here minus is already there, I will be adding a plus here, and here I will be adding a minus sign. Now from this part, what is minus j omega d equal to? Minus j omega d will be equivalent to s plus zeta into omega n. So what now I will be doing is, whatever the value of b is there, that will be equal to minus zeta omega ns plus s plus zeta into omega n. So this is equivalent to what? This is equivalent to 2 zeta omega n is there. So 2 zeta omega n plus s term is there. So s plus 2 into zeta omega n. Now what I have to do? After getting this value of a and b, wherever my equation was there, this in that particular equation 1, I am just doing the replacement. So equation 1 I am substituting. When I substitute that in my equation 1, this will be my new equation. Now what am I doing in this new equation is s plus zeta omega n, one term I am keeping it as it is, plus zeta omega n term I am keeping it as it is. Then omega d divided by s plus omega n square plus omega d square is the term which was left out. So I am going to write it as it is. Now what I do, this is my inverse equation. In this inverse equation, I am taking the inverse Laplace transform for that. When I take the inverse Laplace transform, 1 by s will be equivalent to 1. Now what about the other terms here? The other terms what I will be getting is the first term here, that is nothing but this term. So the inverse Laplace transform for this is e to the power of minus zeta omega n t into cos of omega d into t. And for this second term, the for the second term, that is this total second term will be zeta omega n by d is a constant term. So for this, if I take the inverse Laplace transform, it is e to the power of minus zeta omega n t into sine of omega t. So here what I am doing is, I again resubstitute back what is the value of omega d. So what is the value of omega d? We know that it is equal to omega n into root of 1 minus zeta square. So that omega n value I substituted. After substituting that omega n, this is my new equation. Now what I am going to do is, I am taking the LCM in this equation. So 1 minus zeta square will go here. This term will be as it is. Now root of 1 minus zeta square will go here. This term I am writing it as it is. Since 1 minus zeta square is taken as the LCM, I have to take that outside also. So e to the power of minus zeta omega n into t by root of 1 minus zeta square cos omega dt into this 1 minus zeta square plus what is this term left out? Sin omega dt into sigma. So this is our new term. But what is root of 1 minus zeta square? Let us put that root of 1 minus zeta square to be equivalent to sin phi. And what is cos phi equal to? Cos phi will be equivalent to zeta. How do I get that? That I will be getting by using this delta function. Right? So 1 zeta root of 1 minus zeta square. By using this function, I am getting sin phi as well as cos phi. Right? So cos sin phi is root of 1 minus zeta square and cos phi is nothing but equivalent to zeta. That is, if this is phi, the hypotenuse divided by base, and here if this is the right angle, then this right angle divided by 1. So I will be getting this as root of 1 minus zeta square and this to be equivalent to phi. Now what is tan phi equal to? Tan phi, all of us know that tan phi is nothing but sin phi by cos. That is nothing but sin divided by cos. So I have here sin phi, I have here cos phi. Therefore tan phi is nothing but root of 1 minus zeta square divided by zeta. So what will be in my new C of t value now? New C of t value is 1 minus e to the power of minus zeta omega nt by this will be as it is. But this is of the form what? This is of the form of sine of omega d into t plus phi. Now let us put the value of omega d and phi in the previous equation. So here what will happen? Sine of omega n, substitute that omega d as omega n into root of 1 minus zeta square into t plus what is the value of phi? The value of phi is nothing but tan inverse of root of 1 minus zeta square divided by zeta. Now if I want to find out the error with respect to this particular system, then I know that it is r of t minus c of t. Therefore c of t I have it as already here. And what is the value of r of t? R of t again equivalent to 1 here. Therefore 1 and 1 gets cancelled. I am getting the remaining part as it is. Now the steady state value for c of t, when I will be getting that error, E of ss, when c of t tends to infinity, I will be getting the error to be equivalent to 1. Therefore this is the function with respect to E of t that I will be getting if I consider the signal to be an unit ramp signal. Therefore the steady state says that there is no error between your input as well as output. And according to the second order function, what is your omega d? Omega d is nothing but the damped frequency oscillation, and zeta omega n is nothing but the damping factor or the actual damping, which is also called as the damping coefficient. Now for the equation, if I vary the value, equation A, if I vary the value of this damping factor zeta, then how the response will change is what we are supposed to see now. when the value of zeta is equal to 1, is equal to 0, between 0 to 1, and or between infinity to 0, whatever the values that we are going to give it to zeta, when these values are given, how the system will perform is what we need to see now. So for that, equation A, if we consider that there are two poles, then the condition that I will be calling is between the value of zeta to be between 0 to 1. So at that time, what are the two poles that I am going to consider is, one pole is this and another pole value is this. So the first pole value is minus zeta omega n plus j into omega n root of 1 minus zeta square, and the second pole value is same thing, instead of plus I will be considering that as minus.